Is this just a miracle? So basically, here you can see that we are raising some matrix to the power of e, and it gives a nice matrix. Basically, the matrix in the power is irrational, yeah, but the answer is a really nice rational number because this is just negative of identity matrix. So do you think it's a miracle or it's not? Okay, so basically I will tell that at the end of the video, and I will also give you insights on this equation because this is one of the famous equation as well. But for now, let's try to calculate this manually. So basically we do have a standard way to calculate e to the power some matrix A, and that is from the infinite series definition of e, that is a to the power 0 plus a to the power 1 by 1 factorial plus a to the power 2 by 2 factorial, and it goes on. But how do we calculate a to the power 100, a to the power 200, a to the power 1000? That's really big problem. So that's why to find a to the power n for any matrix A, we do have a standard way, that is to write A in terms of P, D, P inverse, yeah, where D is a diagonal matrix and P is any other matrix. And by diagonal matrix, what I mean is matrix in the form of A, 0, 0, B. That is, all the other elements except diagonal elements are 0. Yeah, because if this is the case, diagonal matrix to the power n will just be a to the power n, 0, 0, b to the power n. You can check this by finding d square or d cube, and you will notice this pattern. And P is in other matrix. So now for any matrix A, how to find P and D? About this I have already talked in my previous videos, and the video is linked over here. Yeah, because once you are able to express any matrix A in terms of a PD P inverse form, then a to the power n will just be P d to the power n P inverse. And I was talked about this in a previous video, which is linked over here. Yeah, and once we have this form, e to the power A will also just be P e to the power D P inverse. I have talked about it in the same video that I already earlier linked. Yeah, and this implies P, so e to the power A 0, 0, e to the power B times P inverse. Okay, so all these details I have already talked in the playlist of matrix algebra, which I will link over here. And after you have knowledge of all these things, now let's begin solving the problem. Okay, the first thing is to express this matrix A in terms of PDP inverse, and now let's do that. Okay, so from all those videos, you might have already noticed that to find P we need eigenvectors, and to find D we need eigenvalues. So let's find the eigenvalues now. For that we need to solve this equation. A minus lambda I determinant is equals to 0. So we have determinant of minus lambda minus pi, pi minus lambda is equals to 0. We have lambda square plus pi square is equals to 0. Lambda square is equals to minus pi square. Lambda equals to I pi. Yeah, and not just this, also minus I pi as well. Yeah. Okay, now we have the two eigenvectors, so that's why we can find the diagonal matrix, which is eigenvector 1 over here, eigenvector 2 over here, and 0, 0. So I pi, this is not I lambda, sorry, this is just minus I pi. I pi minus I pi 0, 0. Okay, now to find eigenvectors, what we can do is we can take two cases. When lambda is equals to I pi, what will be the eigenvector, and when lambda equals to minus I pi, what will be the eigenvectors. When lambda equals to I pi, in that case, to find eigenvector, we'll use the equation involving eigenvector, that is a minus lambda I times b equals to 0. Our a is this equation. So when lambda is I pi, we have minus I pi and then minus pi itself. Yeah, lambda is I pi. So over here also pi only, because our a is this, yeah. And then this is minus I pi again, is it? Yeah. Times, let's say b is just xy is equals to 0. Now we have these two equations, minus I pi x minus pi y is equals to 0, and other will also be same equation. So let's just solve this one. What will be the answer for this one? We just need one answer, and like any other answer is also allowed. Doesn't matter like what we take, all of them will just be same. Okay. So what is the what satisfies this equation? So basically, if I put I over here, x as I, you get minus I square pi minus I pi. Is that? But that doesn't solve the problem. Okay. So wait for some time. Basically, our I pi. Okay, let me put x as I, and then we have this pi over here and y as 1. Okay, so that solves the problem, I and 1. Yeah, I means I square is minus 1, so minus minus plus, so pi and 1 minus pi. Okay, that solves the problem. We get one of the eigenvector. And for next eigenvector, again a minus lambda I times b equals to 0. Yeah, now our lambda is minus I pi, so I pi only, minus pi, pi, and then I pi, and then our b, let it be xy, is equals to 0. Now I pi x minus pi y is equals to 0. So xy can be, we can put x as minus I again, minus I, and then over here 1, because minus I makes it just pi and minus pi. Okay, now we have two eigenvectors, and if we have two eigenvectors, we can find the p just combining them. I 1 minus I 1. Okay, so this is the p. So now we have finally expressed a in terms of p d p inverse. Yeah, now we can write this thing 0 pi minus pi 0 as our p is I minus I 1 1, and then we have I pi minus I pi as our diagonal matrix, and then p inverse I 1 minus I 1 inverse. Yeah. Now if we have to raise a matrix to the power of e, then we know that we can only raise these elements to the power of e. Yeah. And okay, so we get e to the power 0 minus pi 0. Yeah, so is equals to, we can just raise this diagonal elements of diagonal matrix only, because I have already proved why we only do that in one of my previous videos. Yeah, so from there you can get the idea of only why only they. And then I minus I 1 1, and we have e to the power I pi 0 0 e to the power minus I pi, and okay, its inverse. How to find its inverse? So basically 1 by determinant is 2i, and exchange the main diagonal elements and negate the other diagonal I minus 1. Okay, so now e to the power 0 minus pi pi 0. This is equal to I minus I 1 1. Now we know e to the power I pi is minus 1 0 0. E to the power minus I pi, that is also minus 1, is it? Cos minus pi. But wait a second, what it is? So cos minus pi plus I sine minus pi, is that? Okay, now for sine of minus pi. Cos pi is minus pi is just 0, and then minus I sine pi. Can I do it like that? Okay. It isn't really making sense to me though. Oh, sorry. Yeah, now it makes sense because cos of pi is just 0. Nice. Sorry. Sine of pi is just 0. Okay, so this is minus 1 plus I times 0 minus 1. Okay, now it makes sense because earlier it wasn't making sense because I was thinking in terms of rotation. So from pi and minus pi both give minus 1, but how come it get negated, something like that. Okay, fine, you know that this is also minus 1 and 1 by 2i, and this is 1 minus 1 I. Okay, so now we have to multiply this. Yeah, it's somehow like a long boring work, but we will do it, don't worry. Now if I multiply these two, what do I get? Minus 1 0 1 minus 1, so minus 1 basically, minus 1 0 I minus I basically, 0 minus 1, so 1, 0 minus 1, so minus I. Okay, now this one, let me multiply. 1 by 2i, I minus I minus 2i, is that it? So minus 2i, and 1 minus 1 0, minus 1 plus 1 0, minus I minus 2i. Okay, now divide by 2i, we get minus 1 0 0 minus 1. Okay, so we get this nice result because this is just negation of I, where I is identity matrix. Yeah, so we have finally calculated the value, and that is minus 1 0 0 minus 1. Okay, but the beautiful thing is in this is, so what's the beautiful thing that I would like to share is basically this matrix over here, or this matrix is actually pi times 0 minus 1 1 0. Yeah, and just like I, or let's say 1 is in matrix 0 1 0 0 1. Yeah, just like minus 1 is minus 1 0 0 minus 1. I in terms of matrix is actually 0 minus 1 1 0. And if you want to check if how is this the matrix form, just square this matrix. If you square 0 minus 1 1 0, you will just get minus 1 0 0 minus 1, which is minus 1 in matrix. That's why this is I. Now if you observe that this is also I, we are actually having e to the power I times pi. Yeah, and we are getting minus 1. So you see, like from the definitions, from the definition of 1 to be identity thing, that returns the number, and the definition of minus 1 to be negation of 1, I to be square root of minus 1, using these properties, like we had defined what 1 is, minus 1 is, I in real numbers. Yeah, similarly using the same property we had defined different matrix in matrix as well, like from identity properties, unit matrix, other matrices as well. Now the thing with the same property in real numbers, that exactly holds true in like matrices as well, because if we are doing true things, like maths always gives us true things. So this was one of the coolest observation that I made. And not just this, like if you are trying e to the power, let's say, like I will go into another page. Look, let me show it down here. Another cool thing, let me show another cool thing. Now we know that e to the power I alpha is equals to cos alpha plus I sin alpha. Yeah, now if you try finding e to the power let's say I alpha, so 0 minus alpha 0. If you try to find this using the normal matrix exponentiation rules, yeah, from the previous way, the result that you will get is just this thing. So basically cos alpha times 1, so cos alpha 0 0 cos alpha, and then sin alpha times I 0 minus sin alpha 0. Yeah, because I is this matrix, 1 is this matrix. So you basically get cos alpha minus sin alpha cos alpha. Yeah, so you see, like this is so nice. I mean, just the exact version, or like just the version like which is similar to what we had in real numbers. All those properties hold true over here, and this is so nice to look at. Yeah, so basically from here what we can also say is, basically if I take log of let's say minus 1, yeah, minus 1 0 0 minus 1, I will just get 0, okay, 0 minus pi 0. Okay, similarly if I take log of let's say what okay, so let's say I take log of imaginary number 0 minus 1 1 0, and like if you want to find this, you don't need to go over all the calculations. We know that this is just I. Yeah, and we know that the principal value for I is e to the power I pi by 2, and so you know that this is I pi by 2. So you can simply write pi by 2 and then I. Yeah, 0 minus 1 1 0. You can see that the matrix retains itself, because we now know the reason why this retains. This was also asked by Dr. Peham in one of his video, and yeah, this seems so cool, because to have the intuition of why this is retained, we do have that now if we compare it to the real numbers. Now similarly, not just this, if we try to take log of, let's say, this thing, cos alpha minus sin alpha cos alpha, we now know that this is just e to the power I alpha. Yeah, so we will just get I alpha. That's why this is just alpha and then I, 0 minus 1 1 0. So this is so cool, like to be able to predict such huge results, yeah, just from the intuition. And I hope you did enjoy this video. Yeah, we calculated manually, we got the intuition of why this holds true. Yeah, and I think you also watched all other videos on the proofs of why these things work. And yeah, that was it. Thanks for watching. Look forward to seeing you in the upcoming videos too.